Creating a homopolar motor, Physics 30. This experiment is perfect for Physics 30, as it investigates electric and magnetic fields and their interactions with matter. Students will recognize and understand the interrelationships between magnetic and electric fields. They will learn to design, construct, and evaluate prototypes of technology such as an electric motor, and will be able to analyze the ways in which natural and technological sources of electric and magnetic fields influence society and the environment. For this experiment, we will need neodymium magnets, which are permanent magnets consisting of neodymium, iron, and boron, any type of battery, doesn't matter the supplier, as well as copper wire. When performing this experiment, it is important to think about safety. We will be using sharp objects such as knives and wire. We are dealing with electric currents. Batteries may get warm. Neodymium magnets can be very powerful, so be careful, and always wear personal protective equipment if instructed. The first thing that we will do is use pliers and copper wire and bend it into some sort of evenly weighted coil. When you have completed your coil, it should look something similar to this. It's now time to use those neodymium magnets, which as you can tell are really powerful. Then take your battery and put it on top of the neodymium magnet like this. Once you put the copper coil on top of the battery like this, it will start to spin. You have successfully made a homopolar motor. With the right balance and weight, you could have one spinning as fast as this one here. You can be really creative in the different types of coils that you make. So what exactly is a homopolar motor? This is a type of motor that is a direct current or DC electric motor. This direct current powers a rotational movement. The neodymium magnets produce a magnetic field using two magnetic poles. This is what is necessary for the rotational movement. The name homopolar comes from the attribute of the motor, as the polarity of the magnetic field emitted by the conductor, the battery, and the magnets never changes. Let's take a closer look at a homopolar motor, but this time we're going to use M-shaped wire instead of a coil. By now I'm sure you're wondering, well, how exactly does this work? A homopolar motor is an electric motor, so the electricity needs to form a circuit, which is a closed loop of flowing electricity. Electricity flows from the positive end of the battery to the negative end, the top of the battery to the bottom, via the copper wire. As I previously stated, the neodymium magnets are necessary for rotation. They create a magnetic field, which also has a negative and positive end. This field is pushed up through the battery, while the electric current is pushed down through the battery. This causes the copper wire to spin around the magnet, as the opposing forces cause an outward motion on the wire. Once you've mastered the basic coil, you could always try to do a more elaborate design using longer wire. You always have to make sure it's balanced, and you want to pay attention to how fast the motor spins. You could use more than one magnet, or using a different type of battery as well. There are countless ways to implement this experiment. For example, you could find the scientific equations necessary to predict the velocity of the copper wire. Or you could investigate the history of electric motors, or the impact of electric and magnetic fields on society and the environment. Thank you for watching. I hope I inspired you to use homopolar motors as a science experiment in your future lessons.